My name is Tom Dearling. I'm the chair of the Arena Victoria section at the moment. We're here tonight for our technical presentation, Energising the Maritime Industry with Offshore Wind by Jordan Glanville. So just by way of introduction, Jordan is the infrastructure manager at OceanX Energy. In that role, he's responsible for delivering the port infrastructure, marine operations, fabrication and vessel strategy for OceanX projects. I think I'll leave it to Jordan to explain who OceanX are and what they do during this presentation. By way of background, Jordan is a naval architect with over 16 years experience in maritime, port and offshore construction operations. In his very varied career, he's worked at Brisbane Ship Constructions, Germanischer Lloyd, BMT, Chevron, then 11 years at Tech Ocean Energy before joining OceanX in 2022. Through these different roles, Jordan has been closely involved with the development of the offshore wind industry in Australia since its inception. So with that, I'm going to hand over to Jordan.
Thanks for having me. I've got quite a few slides here, so I'm going to keep it pretty casual. I'll probably skip through a few of them. But yeah, my intent today is really to, I guess, give an insight into where the industry is in Australia, some of the technological development, but I will be focusing on floating offshore wind, which is by far the most exciting for naval architects. So I'll give a bit of an oversight of the technological development where we're at. So what I'll go through today, introduction to OceanX Energy and Equinor, who are our project partners for our New South Wales projects. A bit of an overview of offshore wind technology and the technological advancement that's gotten us from where we were to where we are today. Overview of a floating offshore wind farm, what they typically look like, and sort of the key steps during the construction phases, and then where we're up to within current project stages in the industry in Australia. Myself, as Tom said, I'm a naval architect by background. I went into defence out of university, worked for BMT on the consultancy side, then moved into oil and gas, more into the offshore construction side of things, marine operations and running port operations. So a bit of a varied background, but then gradually sort of transitioned with the renewables and offshore wind space through relationships with Star of the South and the executives there. So it's been a bit of a journey, but I think a lot of people who find their way into offshore wind are going to go through a similar sort of state of getting experience that is very transferable within the other areas of the Australian marine industry and sort of transitioning across. So OceanX, we're an Australian company, been around for about 3 years. So we're founded by Andy Evans and Peter Scardellis. So they founded Star of the South. So Star of the South are the first offshore wind farm in Australia in South Gippsland, been around for about 10 years. And OceanX has essentially been set up to look at projects in New South Wales, WA and New Zealand. And we have a key focus on floating offshore wind projects due to the water depths. So for the New South Wales projects, we have 3, the Nova Castrian, Illawarra and Eden. We partnered with Equinor. So Equinor, probably well known to people in the oil and gas space, ex-Statoil. So they're Norway's biggest company, but they're also the world leaders in floating wind. So they essentially invented floating offshore wind. And I'll go through their sort of technological development over the years, but I'm very excited to bring them into the country because we have 2 decades worth of floating offshore wind experience that we can introduce to Australia. So we partnered last year, in August last year, targeting these 3 projects in New South Wales, essentially as a joint venture at the moment, and Equinor will ultimately take over the development of those projects once we land licenses. Each of our projects, we're about 2 gigawatt generation capacity per project. So to put that into scale, that's a very large coal-fired power station, so they're very large scale developments. About $10 billion and increasing with inflation at the moment for each project, and estimating upwards of 3,000 jobs per project during the construction phases.
So are they private proposals for the New South Wales government, or are they coming from the New South Wales government?
The farms themselves. So the way the process works is there's areas declared around the country by the federal government. So they'll declare an area as open for prospective wind farm development. It goes through a process of, I've got a slide on this later, but we can talk about it now. It's probably a good way to frame it. That they'll declare an area as an area of interest. So they do it for South Gippsland. They said, here's this big area, we're considering it for offshore wind. And then they'll go for public consultation, get feedback. So in South Gippsland, they've got 800 submissions of private, public, everyone throwing in their 2 cents about what it should and shouldn't look like. They'll take that into account and then declare an area as open for feasibility licenses. So then private developers will put in bids for a patch of land upward patch of sea, up to 700 square kilometres, and that's your sort of application for feasibility licence rights. So then you get your patch of land, or sea, and you can do your feasibility study, start your front-end engineering design and still working it through. But private developers bidding on these lots. So South Gippsland, first cab off the rank, Hunter following very closely up in New South Wales off the coast of Newcastle.
So what the winning bid is the highest power generation?
No, so it's a very good question. There's a new set of regulations called the Offshore Energy Infrastructure Act, and then the regulations that fall underneath that. And so within that licensing scheme, there's merit criteria essentially. So you can't just go in and say, oh, we're going to build a wind farm. You need, X bank balance and this history of being able to deliver projects and the like. So there's going to be an interesting process of your application needs to focus on the merit criteria, and you're ultimately striving for superior merit in all basis. It could end up in a financial bid way of things playing out further down the track, depending on if there's superior or inferior merit criteria and the like. We're not quite sure how that's going to play out, but it's not necessarily you can produce more power, it's who has the superior merit to actually develop the project.
So Jordan, sorry, just to try and get my head on that.
Yep.
Oceanex and I guess equipment companies, if we were to use housing as an analogy, get like the developers who get the license to build and have own the land or whatever they are, but then actually get builders to come in and do all the building. Is that kind of Oceanex, right?
Yeah, Oceanex is the developer side. So Oceanex and Equinor together are developers. So similar in oil and gas, we are the SO or the beach energy or the actual developer side. And then on the construction side, so your key offshore construction contractors are the likes of Subsea 7 and DOF and Havfram and these big, large offshore construction companies. But you've got quite a few different packages. You've got large wind turbine packages, then your offshore construction, your onshore construction. So we are the developer, ultimate client side, as a consortium with Equinor on our projects at this stage. So at the moment, as I said, we're focusing on Newcastle. So after South Gippsland, Newcastle's the first cab off the rank, hopefully have a declared area later this year. Wollongong in the Illawarra area after that. We have a project in Eden, which is a bit further south. People know the south coast of New South Wales. It's challenging from a grid perspective, but very, very good wind resource down there. And then looking to Bunbury and New Zealand, they're fixed bottom projects. The Bunbury and New Zealand ones are a bit different technology. But ultimately, a pipeline of well over 10 gigawatt when you add it all up, which is quite exciting. So. Equinor themselves, Equinor are historically an oil and gas development company. They've been around for over 5 decades, but they started focusing on offshore wind and particularly floating offshore wind about 20 years ago. So it was very early in there. They recognised this as a very key part of the energy mix into the future. So they have really high growth expectations. So 16 gigawatts of capacity by 2030, which really isn't that far away in the big scheme of things. So they have some large projects around the world, including, well, the largest is the Dogger Bank project, 3.6 gigawatts in the UK in one project. On the floating side, these are the ones highlighted here, and I'll talk to the development there. But the important one here is South Korea in Firefly, which will be a few years before Australia with very similar technology. So they have a pipeline of floating offshore wind projects, which will lead to Australia being very well placed in that to capitalise on the lessons learned. Got a cool video here if it works. This is an Equinor video, but I think it's a good sort of oversight of the scale of what we're talking about. See if the sound works. Worked before.
Challenge and the energy transition are the most complex challenges of our time. Accelerated growth of energy is needed to meet this challenge. Floating offshore wind will play an important role in reaching a net zero society. 8% of the ocean's resource potential is found in areas where the seabed is too deep for a traditional bottom-fixed solution. Floating offshore wind provides flexibility. Equinor is a leading developer and operator of floating offshore wind. Years of experience in floating wind technology testing the world's first floating turbine in 2009, building and operating the world's first floating wind farm in 2017, Wind Scotland, and with the completion of Hydro in Tampa, which will be the world's largest renewable operating data for the world's floating wind capacity. Floating technology works. Wind Scotland has been one of the world's best performing wind farms by capacity factor since it started production. Building on 20 years of floating offshore wind experience and innovation, Equinor has developed a set of design principles and a toolbox that are applicable across floating wind concepts and enable us to select solutions that are both cost effective and provide opportunities for the local supply chain. Water depths, capabilities of local harbors, and the competence and capacity of the local supply chain are some of the main drivers when we consider the technology of choice. Local value creation is integrated in how we plan offshore wind projects, ensuring lasting value for the communities to succeed in this industry. In Norway, the local supply chain has been awarded over 50% of Hywind Tampen's contract value by being competitive in the chosen technologies. This contributes to job creation, local economic value, and builds new hope for future industrial projects. The Dogger Bank offshore wind farm, which will be the world's largest fixed offshore wind farm, has facilitated many local investments in the UK, securing local jobs and skills in this burgeoning industry. Major investments are being made in new manufacturing facilities, vessels, and recruitment to service providers, creating thousands of local jobs. Through our Empire and Beacon bottom fixed offshore wind projects off the east coast of the US, key investments are being made in the local communities of Brooklyn and Albany, New York. These investments could create more than 2,000 jobs. Coexistence with other marine activities and marine life is fundamental for responsibly developing the offshore wind industry. We know, having been offshore for 50 years, for example, we carry out environmental research in cooperation with fisheries and research institutions to ensure we continue to work together with other users of the field. Only by working together can we succeed in developing the renewable energy needed to meet the challenges of our time.
Beautiful. Right. I should have disclaimed it at the start. I do have some information in this slide deck, which is not commercially in confidence, but it is commercially sensitive. We are in a competitive bid process at the moment with many other developers. So I would ask, particularly people online, that information is respected, where I show stuff that, maybe an insight into different things that we're looking at. But I want to make sure that, for the industry, that we're putting the challenges out there so we can get the most value out of the supply chain, because there's no point in keeping it all to yourself, or we'll just get stuck going in the loop. But anyway, offshore wind itself, a bit of an overview worldwide. So obviously a lot of discussion in Australia, but you'll see worldwide it's absolutely booming. So I think that some of the figures which are just mind-blowing. So GWEC, Global Wind Energy Council, they've set targets of 380 gigawatts by 2030 and 2,000 gigawatts by 2050. And the reasons behind that, the offshore wind sort of, I guess, the sales pitch, which is well known nowadays, but if you're not as aware, it's just that capacity to get large scale generation near to our population centres, and it's incredibly difficult to do it in other ways. So it's a really important part of the mix. South Gippsland, you've got very, very high wind speeds and high capacity factors, which can be tapped into the network very, very easily. If we look at New South Wales, for example, the ability to get sort of 4 to 8 gigawatts of renewables into the system near grid and near load is quite difficult. Therefore, you're starting to look offshore, and therefore floating offshore wind in the deep waters makes a lot of sense. The other benefits, the capacity factors are quite staggering at times with the offshore wind side of things. So Hywind Scotland, this is Equinor's second floating offshore wind project. They had a capacity factor of over 56%, So that's the percentage of time that it's creating its full nameplate 2 gigawatt capacity. Onshore wind can be around that 30% is good. 30 to 40 is, 40 is excellent. We're seeing well over 50% in different offshore wind farms. So you're getting towards a base load power when you mix it with other renewables, which is quite important, reduces firming capacity requirements and a lot of different parts of the mix. And obviously the technical maturity, fixed bottom has seen a massive decrease in cost. Floating is a few years behind, but the cost curves are coming down, but it needs scale. We don't have floating offshore wind scale yet, so we obviously still need to get these large multi-gigawatt projects off the ground so we can see those efficiencies through industrialization and serialization coming through. So this is a bit of a roadmap to the process that Equinor have gone through to get where we are now. So Hywind Demo was the world's first floating offshore wind turbine installed in 2009, so 14 years ago now. Essentially, the floating leads within Equinor dreamed up an idea of a wind turbine on a floating foundation. There was obviously many years of engineering before that, a small 2 megawatt turbine back in the day, but that's where it all started. Then moving to Hywind Scotland 8 years later, a 30 megawatt installation with 5 turbines, 6 megawatt turbines. Through each of these stages, obviously seeing very significant cost reductions per unit of energy. Moving up to Hywind Tampen, which is most of those images you saw in the video before are Hywind Tampen, which is a spar type foundation. 88 megawatt, which is actually powering an offshore oil and gas field. But again, a very good technological development for mooring designs and all those sort of different aspects of the challenge which need finessing to the point that now they're ready to scale up to the 300 to 2 gigawatt scale projects. And what was important, as I said, is Firefly. That's an 800 megawatt project in Korea, coming a few years before us, using very similar foundation technology. So we're quite well placed to use the learnings of those projects into Australia. Again, this is sort of indicating some of the steps along the way and the different aspects to design that are really important to see how you get that technical readiness level up. So everything from, again, we've got the size here, 2 megawatt, pushing up to 15 megawatt currently, in the future up to 22 megawatt. And I mean, if anyone, when you drive through the countryside, you see a turbine, it might be a 4 or a 6 on the onshore. 6 is about as big as they get. And we're talking 22 megawatt. The scale of these things is absolutely astronomical. So 300 metre tip heights, taller than Eureka Tower on a floating foundation. But what that does is increase efficiencies, reduces the amount of foundations you need, reduce the number of anchorings you need. So there is a lot of efficiencies with scale, but you really push the limits of ports, vessels, and the like. So it becomes a real technical challenge. On the bottom, you see some of the other areas that are sort of below the turbine, so anchor development, different technologies tested out through the development phases, and mooring systems. It's really important, the different ways of analysing and designing mooring systems. And then cables themselves. So we've got dynamic cables, which have very high fatigue loading. So a lot of technology development and essentially the supply chain keeping up with the technology and bringing this the technical readiness up. I just like this photo, so I'm going to put it in there. But this is Hywind Tampen again. So Hywind Tampen uses spar foundations. These foundations go 80 metres underwater, which I mean in Australia it'd be quite staggering to be able to do that at a port, but they had these with 80 metre draft alongside in a port because the port is in a fjord. So they have 100 metres of water depth alongside the quay, which is quite amazing. Very stable. They actually formed them. It was a slip form concrete foundation. So they would set a bit of concrete, sink it down a bit more, set a bit and sink it down. So quite an amazing process. Obviously won't work in Australia due to water depths, which is why we're moving to a semi-submersible design. But you can see just the scale of these things and the shoreside requirements to support it are quite staggering. This is a typical floating offshore wind farm. So this is an early image of the Novocastrian offshore wind farm. Things are changing as we go through, project development. But essentially we have upwards of 100 offshore floating turbines. The turbine sizing will be 15 to 20 megawatts, depending on technical readiness levels. The turbines are on floating foundations, so steel semi-submersible foundations, which are moored to the seabed by multi-spread mooring. Then we have dynamic inter-array cables connecting all the strings together to a floating offshore substation, and then an export cable to shore. So a lot of steel, a lot of moorings, a lot of rope, and a lot of chain, but essentially everything's floating and moored. Any questions on? No? Foundations, being a naval architect, this got me very excited. We spent a lot of time with the Equinor floating foundation leads, and these are the guys that essentially designed the first floating offshore wind turbines and have worked through to where we are now. The concept for Australia is a steel semi-submersible. Concept for Firefly in Korea is the same. So again, we're sort of one step along, so we can take the learnings from that. Steel semi-submersible, as simple design as possible is key because we need to work towards serialisation and industrialisation of fabrication. 3 columns, a ring pontoon, so that the major flotation is provided by the ring pontoon at the bottom. Turbine on 1 column, which simplifies structural design. A passive ballast system, again, trying to keep everything as simple as possible. Really focusing on mass production, so simplified stiffened plate sections, so we can work towards simplified production lines as possible in the future. And a key, very exciting one, which I found really interesting, was an in-house design motion controller, which Equinor have patented, which I'll show you here, that actually utilises the turbines themselves and pitch correction, yaw correction, and actual gearbox braking correction to maintain motions on the foundations within a couple of degrees compared to what they would be otherwise, well over 10 to 15 degrees in different sea states. So pretty incredible development to get to that point. It reduces the requirements on the hulls themselves, but it sort of shows how much development has gone into this technology and where we are. Don't ask me too much technical about this one because it wasn't my work.
How much power does the active control?
Apparently not much. Yeah, so it's small corrections just to change the loadings on the foundation themselves. But yeah, it's apparently well and truly recovers itself in the reduction in actual movements.
I presume the turbines themselves are weather-vane,
Yes.
or do they do that themselves?
Oh, so the foundations don't, but the turbine does.
Yeah.
Yeah. So that's same as any sort of fixed turbine.
So with the base, is it dynamic or it's fixed?
So the foundations are moored, so they'll have a multi-point mooring. Could be a 4-point mooring. They don't move. Yeah, so they're fixed, and the turbine will move. So in terms of project phases, we talked about before, we are applying for a feasibility license. So that's the very sort of first stage of any of these projects. We need to make sure that it's well understood that getting a feasibility license doesn't mean we have a license to build a project. It's sort of the start of measuring the seabed, understanding what the wind resource is like, and starting through the community consultations and transmission corridors and all that sort of fun stuff. That's where we're applying to get a license. So we'll have 5 to 7 years of feasibility activities. The key activities through that from a marine perspective are geophysical and geotechnical investigations, so actually mapping and testing the seabed. We need that to be able to design our moorings, essentially. So, we need suction piles or pile foundations. So there'll be a lot of geotechnical, geophysical campaigns. Floating LiDAR, this image here, whilst it might not look like much, that's the first vessel-based work in offshore wind in Australia. So that was the floating LiDAR buoys for Star of the South. So this little towed unit here, 6-metre buoy with a LiDAR unit on top, so a laser unit that measures the wind speed up to about 300 metres. Quite accurately, that was moored at sea for a bit over 2 years to measure the wind resource, because you need proper data on what the wind's doing so you can work through your bankability and actual returns. So that'll happen at all wind farms. They'll need a floating LiDAR unit. That's like all wind farms will need geotechnical, geophysical investigations. You also have environmental baseline studies to understand what's going on in the environment, measuring benthic habitats and all the rest. So a lot of work required on the feasibility side from a marine perspective. Obviously, all the design, front-end engineering design happens at that stage as well, but I'm focusing on the boats here because that's what I like. Moving into construction. So I do have, I'll flip back and forwards between these, because for a floating project, what becomes really interesting is that the span of the construction and how much overlap there is. So we have a mooring spread, we might have 4 moorings for 100 turbines. There's 400 moorings out there. They won't happen. You're not going to have time to do all your moorings and then come and do the next bit and then come and do the next bit. So it becomes a real logistical challenge, almost more than an engineering challenge. It's the logistics challenge of how you overlap all of these construction activities for, let's say 4 years. So we'll do anchoring and mooring using a construction support vessel like this one here. That'll also do the inter-array cables, hooking it all up together. Then we'll have large cable lay vessels. Cable lay vessel like this for the large export cables. For a fixed bottom project, they use large jack-up vessels, and that's also an important differentiator for floating wind, is that a lot of the heavy offshore construction aspects, like these very bespoke large jack-up vessels, all that work moves to the port. We're putting it all together along the quayside, and then we just tow it out. So in some ways, it is easier offshore. And then this is essentially the tow out of a turbine. I'll jump to the construction in the next phase, but then a really important part for the Australian industry as well as this O&M phase, so operation and maintenance. So we have 30 plus years of maintaining these units offshore, which need full-time vessels. And there's some really incredible opportunities for Australian design and fabrication for those vessels.
When you get your feasibility licence, does that open up government funding to support all that feasibility work you're doing?
No, it's all privately funded. So, for example, our projects, each project we expect to spend upwards of $200 million in the feasibility phase alone. So there's a lot of work for the industry, all privately funded, without government support to get through that feasibility and front-end engineering side of things.
So does that include the end-to-end value chain of the transportation, building the boats, that will actually fits into this in terms of the logistics?
In terms of the feasibility stages, well, we'll assess what we need. And I guess our job, we're not vessel operators, so it's to bring industry along, because ultimately we will charter vessels for that time, and that will be the business case in itself. So in terms of early feasibility studies, we need to understand sea states, operability limits, what designs can do. And this, I work for BMT, but I know they're doing some incredible stuff in CTVs worldwide. Really good hybrid designs and different ways of increasing sea state operability, so you can use smaller CTVs where otherwise a larger, go back to that, that's an SOV, so a large, sort of like an offshore PSV. But moving towards being able to use smaller vessels, which we used to do a lot of this sort of thing in Australia, build them locally and design them locally would be a fantastic outcome. So going into the construction phase, as I said, it's a real sort of overarching logistical challenge that we need to install anchors, pre-lay the moorings, have the floating foundations fabricated and transported and assembled, ready to go, then turbines assembled, towed out, installed and commissioned over a long period of time and for a lot of units. So when you start looking at it, the engineering side of what we're installing is quite technically advanced. We sort of know the challenge, we know roughly what it's going to look like. The real challenges come in the logistics side and how you actually manage such a behemoth of a project. So it's quite an exciting challenge.
So for the givestones, farms, are there going to be a number of different developers?
Yes.
Just different.
Correct. Yeah.
So
givestone will be fixed bottom. So the water depths are sort of 40 to 70-ish meters. 70 is about where you max out fixed bottom. So slightly different in the construction phase. You're taking fixed foundations out and installing them, and then taking that large jack-up vessel offshore to install the turbines offshore, whereas we'll be doing that in port. But yeah, you're right. You're applying for 700 square kilometres maximum, and each of those will be an individual developer. So Star of the South will likely get a licence. Who knows the way it'll play out, but Star of the South, then all the other developers are bidding for the other, could be up to five individual developers, similar to oil and gas, where you'll get your patch of land and then develop the project.
So like up in Hunter, where you're aiming at, there'll be a number of different developers, all with demand on shipping and port space.
That's right. Yeah. So that's I guess the unknown, the way it's going to play out in terms of projects falling into a line of one after another. How many can be done concurrently? It's very early in the piece to understand that, but what would be the best for the industry is an extended period of good amounts of work rather than a flash in the pan of everyone just doing everything at once and then disappearing. So yeah, it's going to be an interesting challenge when you've got 5 developers. That's $50 to $100 billion of investment in Bass Strait just for offshore wind over the next decade. So it's, after feasibility, but even through feasibility, the work is fairly staggering.
There's a question online.
Yep.
From Max. Yeah, great presentation. The feasibility of your business dependent on an assumption of subsidy in future for low emission power, or do you think the project will deliver sufficient returns operating in the NEM in its current form?
Yep, fair question. I don't want to delve too much into financials tonight. It's certainly not my main area. What we've seen in the international case is typically a system like the CFD, contract for difference offtake type arrangement, which is government led. And the idea is to firm up revenue streams so that we can obtain funding and develop projects. But what you see through that process is that strike price for CFD is rapidly decreasing as the technology gets advanced. So we are in early phases of a new industry. There's going to be increased costs. The idea is to set up a mechanism through government, but ultimately supported by private industry that reduces that cost as quick as possible. But every new technology has increased costs to start up, and we're starting a whole new industry in Australia. So yeah, fair to assume costs will be higher at the start. So onto the foundations themselves. This is sort of where I was saying I want to throw the challenge and sort of give an insight into some of the complexities of floating wind. But again, we've done a lot of work in this stuff. Others may not have, so please keep stuff within the circle of trust as much as possible. But when you start looking at these foundations, there's different scenarios for fabrication and assembly. We ultimately need a large floating foundation alongside of the quay that we can start putting stuff on top of. The way we get it there could play out in many different ways, and we need to look at all these different options through feasibility. So scenario one is essentially block fabrication. So if we look at the foundations themselves, modularized, we have blocks. So we've got columns, pontoons, braces. So they can be fabricated overseas, put together overseas, dry towed on a heavy lift vessel, brought to the assembly port, and then towed out and installed. That's scenario one. That would be essentially the lowest version of local content. That's still a lot of local content, even just doing that part of it. Scenario two, blocks fabricated and brought in on a heavy lift vessel and then assembled quayside. I've got a slide next which shows what that looks like. That's a massive amount of work locally as well. The land required for that is incredible, and a lot of fabricators to bring it all together. But that allows you to break it all apart, fit more in a heavy lift vessel, and bring a lot more of the work locally within the port areas. You put them together within the port limits, wet tow them to the assembly point, which I'll show you in a couple of slides, and take out and hook up. Finally, scenario three, which is the holy grail, is utilising Australian supply chains. Could be a mix of Australian and overseas, but similar in defence projects where we've had modular designs, building parts around the country, bringing them together for assembly wherever that may be, and then assembly of the turbines and tow out and hook up. So once again, we aren't fabricators as a developer, but we want to bring industry along. We're doing a lot of work in the background with different fabricators, steel producers around Australia to make sure that there's an understanding of what this could look like in the future and the volumes, because the volumes are staggering. You get a lot of comments like, we don't have anywhere that can build that. We also haven't had to build this. We're talking about 5,000 tonnes a week for many years. So the opportunity for greenfield development to meet these challenges is fairly significant. And a lot of it comes down to that value add of, what do we want to do in Australia? What do we want to be as a country? And do we want to be doing fabrication here? So our role as a developer is to try and bring people along on the journey and put the challenge out there. And that's what we talk to anyone and everyone about.
So Jordan, what's WTG?
Oh, wind turbine generator. So that's the turbine tower and blades. When you see and it's usually from European, so they say BTG. It's everything above the foundation. So if we look at scenario two as an example there, this is what the local assembly would potentially look like. So heavy lift vessel bringing in block components, and you'll have multiple stations within the port area or nearby, putting it all together, making the final assembly, then loading out and floating off. So There's a lot of technical challenges in that themselves. Float offs of large structures within port limits or nearby is a challenge. We could be launching them off barges, ship lifts, graving docks, whatever, but it needs to be an efficient process. So presented at the Ports Australia conference last week, just trying to, we're years away from constructing, but we need to think about these challenges. Different companies around the world are coming up with some fantastic ideas, but I saw one last week with essentially a slipway but bespoke for assembly of these modules, where you move down stations and then slip into the water. So pretty exciting stuff.
What was the timing for this work? Is it happening at the same time as submarines and under?
When are the submarines happening?
Is resourcing?
Yeah. Submarine nuclear can provide it back. Yeah. There will be resource constraints, and I've highlighted that later on as a key area that Australia is going to be challenged with. But it's across the board. I mean, already we're struggling to hire people in different areas. But maritime engineering and seafaring is a bit of a dire strait in Australia, and it's something I'm a bit passionate about, working with the Maritime College. So I'll save that one to the end. But we need to start inspiring people. So once we have the foundations assembled alongside at the port, this is how we put it all together. So typically you'd have multiple stations where you prepare the foundation, you'll assemble the turbines. So within the port, you'll have a very, very large ring crane. These cranes are staggering. We went to Scotland and had a look at the port of Nig in the north of Scotland, where they're doing fixed foundation loadout. So not even this, this size, but the ring cranes are just blow your mind. They're sort of lifting 1,000-ton structures 200 metres into the air. So they're quite amazing. Obviously have very high bearing pressures, but you're putting it all together at the quayside rather than that large jack-up vessel offshore, which is much more expensive than that crane. Then you go through the pre-commissioning process and tow off, tow out, hook up to your moorings and connect your inter-array cables. And this is that high wind tampon again. This is in a deep fjord, so it still blows my mind, 80 metres underwater there. But that's the large ring crane putting it all together quayside. So you can manage that operation much better than you can offshore, but it does bring a lot more work to the onshore components of these projects. Tow out, you have a lead tugger, trailing tug and a couple of harbour tugs, and then hook up offshore with a construction support vessel, usually. Quickly on the project schedule where we're at the moment. So we partnered with Equinor late last year. Consultation is open, as we talked about. So we're targeting an application for a licence later this year. That's all things going to plan. This is led by DQ, Department of Climate Change. So we're hoping to get a licence awarded next year. This is a very ambitious timeline, but stars align. We will work on feasibility for sort of 4 to 5 years, reaching FID in 28, and then starting with the procurement, construction, and moving into installation and tow out, or fabrication, installation and tow out. Obviously, after that, let's say we're constructed in 2032, 33, 30, most likely more like 40 years of operation after that. So, very long-term jobs and stable jobs for the local economy. There's the O&M, simply technicians, but vessel operations and all the shore side to support these projects is quite significant. So I've tried to summarise a couple of key challenges from a marine perspective. Supply chain is obviously the most obvious one for everyone. We are a small piece in a big worldwide puzzle. Everyone's running at this at a staggering pace. So I think there's a few countries like Germany, Belgium, and another one in the area. They propose a target of 150 gigawatts, just over 3 countries of offshore wind. So we need global significance in Australia, and to do that we need a pipeline. So it's a strongly held belief that we need many projects to get up as quick as possible so that we can start attracting the OEMs, the cable manufacturers, to bring as much as possible onshore and be big enough and ugly enough to bring this work locally. The supply chain will be constrained through all areas, fabrication, vessel supply, cables, turbines themselves. But the way you overcome that is to get enough projects up that the market can build to meet it. You need a business case. There's money to be invested in this stuff. You just need enough of a certainty of supply, offtake, and work to be able to build that. Logistics, as I said, the more you dig into these projects, it becomes less of an engineering problem and more of a logistics problem. It's how do you bring in a heavy lift vessel once every 7 days, offload this stuff, put it all together and get it out and keep doing that for 4 years. So staggering challenges from a logistics point of view, but opportunity for optimization, and that's where sort of the port operations and vessel operations really can sort of make massive differences to how these projects play out in the long term. Port facilities, we haven't talked about it much, but DNV did a study for offshore wind development worldwide and named port facilities as the #1 constraint. So the ability of ports to be ready for offshore wind farm development, get areas cleared, quayside developed, enough water depth and the like is the #1 challenge identified worldwide, and it's no different in Australia. So South Gippsland, they've identified Port of Hastings as the key construction port. There's a lot of work to be done there. It's well located. Barry Beach is much closer, but there's a lot of challenges for people who know the area. It's very shallow drafts and the like, but we need a lot of port facilities. You're not going to do it all out of one area. That's probably the longest lead time as well in terms of being ready for a project, because it's a challenge in that they need to be working on that many years before we start cutting steel, but they need a business case to be able to support that as well. So it's a bit chicken and egg. It's a hell of a challenge, but we're doing a lot of work in the background. Different port operators around the country. Industrialisation of fabrication, so bringing that cost of fabricating the foundations down is a real challenge for floating, but definitely seeing good advances in the international experience. And I heard a really good example. Someone said, at the moment we're building floating foundations like we're building ships. So, it's a bespoke one-off. We're building a ship, it changes each time, but we need to build them like cars. It needs to be industrialised, heavily standardised as much as possible. So it's a production line, and we can get that cost right down. And workforce. So workforce, we're in the early stages and it's already hard to fill roles. I think everyone would agree that the maritime industry and sort of getting into either maritime engineering degrees or, what sort of scares me a bit more is the seafaring side of things. It's not well known to people that the maritime industry is an interesting, exciting, varied place to work. School leavers aren't really aware of it. I grew up in Queensland. I had to find about naval architecture myself because I like boats. But everyone sort of found a bit of a funny way into the marine industry, and it's similar with seafarers. They either know someone who's in the industry, or it's an uncle or brother or whatever. It's not that well known, and we need thousands of jobs filled in the future to meet these energy needs of the country, which are, there's very large policy targets for how the energy transition needs to go. So there needs to be a lot of work on sort of setting the task early on, what the roles look like and where we need people to be, and then targeting people early on. We need to be working now for a workforce in 2030. So we are doing a lot of work in that respect. But it's a challenge. I talked to the Maritime College about a month ago. I don't know if others have talked to them recently, but the numbers of naval architects have dropped from about 120 10 years ago to 13. So it's not good. A lot of different reasons for that, but I think it's important for everyone to sort of take their own little piece of that puzzle and try and get people interested. I presented at the CDC conference recently and trying to focus on that reinvigoration. I think there needs to be a national campaign for it, but to try and highlight the opportunities coming for offshore wind. Defence is going to need a lot of people too. We've got defence, oil and gas is still going, decommissioning is coming up. So there's all these different competing interests for our people, but we've got to start now. Some key opportunities. This is a very short list. There's obviously a lot more, and where I think Australia can sort of look at different ways of, excelling in different parts of the puzzle. I think on a fabrication perspective, we've talked to a lot of local fabricators, and Australia is very good at smart fabrication and reducing the number of man hours required and trying to do things efficiently. So that optimisation, serialisation part of fabrication, I think there is good opportunity within Australia. We're working with different fabricators to try and, again, set the challenge. You're trying to say, this is the opportunity. We're talking about millions of tonnes of steel. Can we get it to a cost where we are competitive in country? What's the differential? What does that look like for the country? But is it worth keeping it here? Crew transfer vessels, as we talked about earlier, each of these wind farms will require several, 2 or 3 crew transfer vessels, dependent on the sea state. So, up in the Hunter, we're still very early stages, so it could go either way of an SOV or multiple CTVs. But those vessels are very similar to what we used to do a lot of in Australia, still do a fair bit of, but fast aluminium vessels with clever design. So, excited to see what Australia can do in that respect. Mooring analysis and optimization, every site is different, and there's some really experience within AIMOG and the like, different companies in Australia who are very strong on mooring. I think that's a good place for people to target in these particular projects from a design side. The foundations themselves, a lot of that IP is held within European companies. It'll be difficult to break into those sort of areas, but mooring and the localized aspects of installation will be, that's the real interesting stuff we can do here. Finally, that port development and optimization, that flow of equipment through a port and trying to maximize throughput in constrained areas will be your make or break projects. So being able to get the most out of rather constrained spaces will be a key challenge, and I think we can, talking to a lot of companies internationally, they have some good options on this, but there's really good opportunity for optimization. So finally, done a lot of talking. Offshore wind is rapidly becoming a key component of the worldwide energy transition. It's real and it's here, it's happening, everyone's running at it, and it's Australia's turn to sort of get on board, which we are in a good way. So when I was in Norway late last year, it sort of felt like Australia had spent a lot of time playing catch up and we're sort of dabbling along, but the way that Australia's caught up in the last 2 to 3 years is actually incredibly impressive. So we have regulations in place, we've got a licensing regime out there and working. A lot of countries have taken a lot longer to get there. So we should be proud about where we're at. Now it's time to sort of build that pipeline and really start bringing the OEMs and the different developers into the country. Engineering and optimization will unlock marine and port capacity, so we'll be constrained on vessels and port areas, but that gives us an opportunity to really optimize and try and get as much as possible out of our resource. There is significant opportunity for innovation in select areas, and I think it's good to be involved with developers early to try and identify those sort of areas where you can specifically get involved and where the key skill sets lie. Our sort of role at OceanX is, I guess, again, setting the challenge and educating industry on the different aspects, and then also linking up with the global developers like Equinor, so they know what we have in country, which is quite impressive in a lot of different areas, because big developers will come in and they've got long-standing relationships, and we need to always be looking local first. Finally, workforce development needs to start now. We're going to end up with a lot of ships and no one to drive them, so it's going to be a bit of a challenge.